Okay, so this is properties of parallelograms. A parallelogram is a quadrilateral with two sets of parallel sides. So these two sides are parallel, and then these two sides are parallel. Opposite sides are parallel. They're also congruent. So these two sides are the same length, and then these two sides are the same length. The diagonals bisect each other. I'm going to draw you a separate picture for that just so it doesn't get so crazy. So I'm going to draw that up here. So remember, bisect means cut in half. So these two would be the same length. And then these two are the same length. And then all consecutive angles are supplementary. So consecutive angles means in a row. So that means that, how do I want to do this? These two angles add up to be 180. These two angles add up to be 180. These two add up to be 180. And the same thing happens down here. These add up to be 180. So I take 180 minus 119, and that would be 61. So this angle is 61 degrees. I also know that these two angles add up to be 180. So I do the same thing. 180 minus 61, that's 119. I also know that these two add up to be 180, and we actually already did this if you notice. So it would be 61 degrees. So same thing. We know that opposite sides are going to be congruent. So if this side's 15, so would this side. So FE, 15. Over here, if DE is 10, CF is 10. The diagonals get bisected. So that means if CG is 7, GE is 7. And then the last piece of information we need is up here. It says FD is 22. So here's FD. The whole thing is 22, and remember, each of these would be the same length. So you would take 22 and divide it by 2, and each part would be 11. So GD is 11. All right, so that's one parallelogram. Find the measure of KL and the measure of angle J. Again, I'm going to start with the sides, but what you know is that opposite sides are congruent. If they're congruent, we take the equations and we set them equal to each other. I could subtract 7x from both sides. I get negative 2 equals 5x minus 22. Add 22 to both sides. You get 20 equals 5x. Divide by 5, and x is 4. Since it says find the measure of KL, I need to take this 4 and plug it into KL. So 7 times 4 minus 2, so that would be 26. So KL is 26. Okay, I'm going to keep going. So then Alex mentioned that when you look at these angles, they ended up being congruent. So opposite angles end up being congruent. So we would just set those equal to each other. 10y minus 27 equals 2y plus 29. Subtract 2y from both sides. Add 27. Nope, how about 56? Divide by 8. Y equals 7. Just make sure you read carefully. It says find the measure of angle J. So I'm going to take that and plug it into angle J. So 10 times 7 minus 27, which is 43. So angle J is 43. So this time, they're not opposite angles, but they're consecutive. So when I labeled the diagram for you, we said that these two should add up to be 180. So this time I take 3x plus 5 plus 9x minus 17, and I set it equal to 180. I can combine like terms, so 3x plus 9x is 12x. Positive 5 minus 17 is negative 12, and that equals 180. I can add 12 to both sides. 12x equals 192. If you divide by 12, x equals 16. Make sure you read the question carefully. It says find the measure of Q and find the measure of T. So you need to plug that into both angles. So for Q, it'd be 3 times 16 plus 5. So that's 53. And for the other one, it's 9 times 16 minus 17. That's 127. Okay, then the next one, in parallelogram STUV, TV is 74, so I'm just going to highlight that. Here's TV, it's a diagonal. It says WV is 4x plus 1. So this is WV. There's two ways you can do this problem. I'm just going to show you one way. So this is 74. I know that the diagonal gets bisected, so I'm just going to cut the 74 in half. So 74 divided by 2 is 37. So this half right here is 37. So 4x plus 1 equals 37. Subtract 1 from both sides. Divide by 4. X equals 9. So, same thing in proofs, we are going to write down what we're given. Oh, wow, what am I doing? Okay, let's try again. Parallelogram ABCD, and then you write the word given. If this is a parallelogram, we know that opposite sides are parallel. So I'm going to mark those as parallel. I'm going to write down that BC is parallel to AD and AB is parallel to CD. And I'm just going to write definition of a parallelogram because that's just one of its properties. Since those are parallel, that tells us, if you forget, that during a proof you're looking for an angle pair. So if I highlight the two that are parallel, and I highlight a line that's touching both of them, you should see how these two angles get outlined completely. So I've outlined angle 2 and angle 3. So angle 2 is congruent to angle 3 because those are alternate interior angles. And then I'm going to highlight the other direction, these other two parallels, in blue. So blue, blue, here's a line that touches both of them. Hopefully this time you can see that now I've outlined angle 1 and angle 4. So angle 1 is congruent to angle 4. Again, those are alternate interior angles. After you use your given, so I used this, we look for vertical angles or a side that the triangles share. And the two triangles share this side right down the middle. So we say AC is congruent to AC, and we say reflexive. Once you have 3 marks on both triangles, and remember, We don't include these parallel marks, like we don't count those. So I have angle and then a side and then an angle. We need to write down the shortcut, so angle, side, angle. And we need to say that the triangles are congruent. So I'm going to call the top triangle ABC. If I say ABC, I would have to do CDA to get my marks to match. And then after that, you can write down the sides they're asking you to prove are congruent, and we say CPCTC for that, which means corresponding parts of congruent triangles are congruent.